Alright guys, so I'm gonna go over this worksheet, which was the one you were supposed to turn in last week. Hopefully everything is working fine, unlike last time when the pen was going crazy, but hopefully today everything's working fine. The first page was the one that we did on Monday and you were supposed to turn in on Tuesday, and it was talking about the probabilities of getting a pumpkin or no pumpkin on this maze. The first thing you have to do is create an area model. So you start by drawing your rectangle. And there were three paths. You had an upper path, middle path, lower path. So you divide it into three. And then the first path goes to no pumpkins and pumpkins. So that's 2. No pumpkins, pumpkins. And then the middle path just goes to pumpkins, so the whole thing is for pumpkins. And then finally the lower path goes to pumpkins and no pumpkins. So I'm going to divide it into 2, pumpkins and no pumpkins. Okay, now I have the first part that is divided into 2 pieces. The second part is divided into 1 piece, and the third part is divided into 2. I need to find the least common multiple in order for me to know what number I need to divide the whole area model by. I can count by 2s over here and do 2, 4, 6, 8. I can count by 1s over here, 1, 2, 3, 4. Count by 2s, 2, 4, 6, 8. And if you notice, the least common multiple is 2. That means that I have to divide this section into 2s, this section into 2s, and this section into 2s. Now, the top section is already divided into 2s, so I can leave that one alone. But the middle section, that one is divided into 1, so I need to cut that into 2 pieces. So I'm going to cut it right here. So now I have this piece that has pumpkins, and then I have this piece that has pumpkins over here. And then finally, the last part, this section over here is already divided into 2, so I don't need to do anything with it. If you notice, I can count them, and now I have 1, 2, 3, 4, 5, 6 pieces. And then of those 6 pieces, I have 1, 2, 3, 4 that are pumpkins. So I have 4 out of 6, which is the same thing as 2 out of 3. And then from those, I have 1, 2 that have no pumpkins. So I'm going to do 2 out of 6, which simplifies to 1/3. This is where I was asking you guys to figure this out, because I wanted you to show me where these answers that they got were coming from. So they got these answers down here. Notice that this area model, let me get that. This area model is the same area model we made here. And then this 2/3 is the same 2/3 we got here. And this 1/3 is the same 1/3 we got over here. So we're good to go. Now, from that, you needed to answer the following questions. Number 1 says, how does the area model that Kyra created compared to the tree diagram from your work and student activity? Student activity sheet 2. I can't even talk anymore, it's this late. But you're comparing it to the tree diagram. So I'm going to make a Venn diagram to kind of compare it real quick, and then you can write it in sentences. Tree diagram, and then area model. They both show probabilities. This one has branches. This one has a rectangle. This one you have to divide it into equal pieces, while this other one over here, you could just put probabilities on the branches. There's more to it. You can add to it or use this to write a nice paragraph, okay? Now, for the next question, number 2 said, design another maze the group might create, perhaps try more branches and then show the possible outcomes. You make your own maze. So you make your own starting point, and then you decide how many pumpkins or no pumpkins you're gonna have, and then just start drawing some branches that go from here to there and so on. And once you finish that, create an area model that shows the different number of possibilities that you can get. I'm not going to do that for you because I think you can create that one on your own. It's an opinion. You decide how you want to make your maze, just as long as it matches your area model. Okay. Now from here, we had this map that was kind of complicated and crazy. So for the first part, we were saying that this path can go to one way, that's 1. It can go through here, that's 2. It can go through here, that's 3. And then it can go through here, that's 4. And then finally it can also go through here, that's 5. So path 1 could go to 5 different places. Okay, I'm gonna erase that and just rewrite this over here. That was going to 5. And then the middle one is going in the same way, but you're starting on this path right here. So I can go all the way up, and if I go through those 2, that's 2 different ways it can go. And then I could go through here, through those 2, and then those 2 places, so another 2, we already have 4. And then finally, if I follow this path down straight this way, that is another 1, so 5. This one can go to 5 places. Okay. Same idea for this third one. I can go from here all the way down there, that's 2 places, right here and here. And then I can go from here all the way over here, that's 1. And then I can go from here to here and here, that's another 2. And then I can go from here all the way through here, that's 1. So that's a total of 6 places that it can go. So far we have 5 for that one, 5 for that one, and 6 for this one. And then finally we have one over here that says no pumpkins. Or sorry, that's the end. But this one I can go from here, 1, 2, 3, so this one can go to 3 different places. Okay. So now that we have those numbers, we can actually go and draw our area model. So you have your area model and you have 4 original paths. So I'm going to divide it into 4 pieces. And then the first one has 5, and then we said 5, 6, and 3. So I'm going to divide it into those pieces. So this one's going to have 5. So 1, 2, 3, 4. This one's going to have 6. 1, 2, 3, 4, 5, 6. And then this one's going to have 3. Okay. So we have that kind of split up. And then now I need to find the least common multiple. I have a 5, a 6, and a 3. 5, 10, all the way to 30. Right? And then 6, 12, 18, all the way to 30. 3, 6, 9, all the way to 30. You'll realize that 30 is the least common multiple. That means I'm going to divide each of these into 30 pieces. Now if I have 5 pieces here, 1, 2, 3, 4, 5, and I need to have 30 in total, that means I'm going to put 6 in each, because 6 times 5 is 30. Same thing over here. And then if I have 6 pieces, 1, 2, 3, 4, 5, 6, and I need to have 30, then that means I gotta put 5 in each of these. And then finally, if I have 3, there should be 10 in each, so I can make 30. Okay. Now I didn't label which ones were pumpkins or not pumpkins, because I think you can go back and figure that out. But I can tell you that your fraction is going to be out of 120, because I had 30 pieces here, 30 here, 30 here, and 30 in the last part. 30 times 4 is 120. Whatever you get here, that is your fraction. Simplify it and it'll be your answer for number 3. Let's move on. Let me erase this part before we do. Number 4, I'm going to give you an example. I'm not going to tell you exactly what it is because I don't remember the fraction from the top. But let's say you had, on the fraction for number 3, you ended up with 3 over 8. So if 8 people go, 3 people get a pumpkin. Okay? And they want to know if 50 people go, how many people will get a pumpkin. Then you would set up your fraction. 3 out of 8 equals something out of 50. Cross, multiply, and divide to find what x is. Number 5, it's asking you where would you put the pumpkins if you gotta choose the top 3, you wanna give a lot of pumpkins. So if I go back to the maze, there are 6 paths. 1, 2, 3, 4, 5, 6. Find the ones that have the most paths coming to it. For example, this one that I just circled has 1, 2, 3, 4. 4 paths that lead to this little space right there. Find the ones that have the most paths leading to it, and those are the top 3 that you want to choose to put your pumpkins at. Okay, that was for question 5. Question 6, if you don't want to give the pumpkins, at which 3 x's should you put them? So the opposite of number 5. And then number 7, what would a maze look like with all equally likely outcomes? So think about that. I'm going to give you a quick example. If I start here and I have 3 paths, this is not a maze because it's a boring one, and we want equally likely outcomes. These would all have pumpkins and they only have one way to go. So you have 1/3 chance of getting to here, 1/3 chance getting here, 1/3 chance getting there. Okay. Now create one that's a little more complicated than that you end up with fractions that look like this. All fractions the same for every single path. Okay. Let me go on to number 8. I'm going to try to get it all in one video. Hopefully it lets me do it. It says, because this year's maze was such a success, Emma draws a plan for the next year. Draw a maze that fits her plan. So first of all, we're looking for something. I'm going to draw really simple. Hopefully you can get it. That has 3 original paths. So I'm going to have my starting point, and I'm going to draw 3 original paths. So this could be the upper path, middle path, and the lower path. And then from here, I'm just going to put yes and no. So yes and no. I want this one to have 4 ways that it can go. 3 of them yeses, so maybe I could do this. And then 1 of them no. And then the middle one should have 1 yes and 1 no. And then the lower path should have 2 no's and 1 yes. So I can even connect it there so that it can go all the way to the yes. Right? Looks a little complicated, but that is what this is telling us to do. You can make it the same way, or you can do another one. It's up to you. It says find P of y. We're going to use this box that they already drew for us. This is divided into 4s, 2s, and 3's. The least common multiple of these is, let's try it out, 3, 6, 9, 12, 2, 4, 6, 8, 10, 12, and then 4, 8, 12. Your least common multiple is 12. That means if there's 4 pieces, each of those should have 3, because 3 times 4 is 12. Each of these should have 6, and each of these should have 4, so that they can all add up to 12. 12 plus 12 plus 12 equals 36. So to find the probability of yes, I need to go in there and add all the ones that have a yes. So I would take one of these, so 3 plus 3 plus 6 plus 4, and I'm going to put that here. Whatever I get, I'm going to simplify it. Okay, I'm not going to finish it off. Oh, and I'm missing one. This other yes. I'm not going to finish it off because I think you can do that. You can add it for yourself. And then same thing for P of n. Go and count the ones that had an n. So like this one, that one over here, that one, and that one. Okay, just count them and you should be okay. Number 9 says you can use an area model to analyze the probability of situations that involve more than one stage. The following example involves selecting a marble yellow, red, or blue from a jar and the cube yellow, red, or green from another jar. This is like the one that we did with that Punnett square. They already gave you the Punnett square right here, and they gave you the tree to make it a lot easier for you. Find P of RY. So all you have to do is count on this one, all the ones that have an RY, like this one right here, this one right there, and that's it. That's 2 out of 16. Simplify it. Over here to find RY, I have just this one right here, no more RYs. So I gotta go multiply 2/4 times 1/3 and then see if it gives me that same thing that they're saying there. Okay. And then probability of at least one red. So find all the ones that have at least one red. This one has at least one red, that one, that one, that one. Okay, that's 1, 2, 3, 4, 5, 6, 7, 8, 8. So 8 out of 6, is that more than 8? 1, 2, 3, 4, 5, 6, 7, 8. 8 out of, oh, I'm sorry, this was 12 for the other one. I thought there were 4 rows. 8 out of 12. Simplify it, and that's what you get. And then same thing on the tree. Just go in there and find all the ones that have at least one R and add them together. They're already giving you the fractions, so just work with that. Just add those fractions, and that should give you your answer. And then finally, probability of both being the same color. Same thing, just find all the ones that have the same color, and you should be good. Alright guys, this is due by Friday, so make sure you turn it in. Don't forget. And if you still need help, you can still find me for tutoring in room 215, morning or after school.